Hello everyone and very warm welcome to all of you at this amazing platform of PW Gulf. My name is Aman, your favorite maths buddy, and I hope you are making the best out of this our revision series. In the previous session, we talked about trigonometry. So in this session, we are going to talk about a baby chapter coming out of trigonometry. What is this baby chapter? Baby chapter means a chapter deriving all its energy from trigonometry. What is that chapter? This chapter is known as the application of trigonometry. When I taught you about trigonometry, I told you about the application of trigonometry. I told you that trigonometry helps astronomer calculate the distance between the two stars, the distance between the earth and the stars, or the big structures which we have built. Structures like pyramids and all, the big buildings, their heights and distance, this all can be calculated using trigonometry. So if this big is the application of trigonometry, so definitely there should be a separate chapter altogether for that. That is the reason we are having a separate chapter which is known as application of trigonometry. So let's start the chapter. Why waste any more time? In this particular chapter, there is nothing new. First of all, quick read. What exactly is this? In this particular section, I'll make you revise the few segments of trigonometry which we are going to use. Exactly whatever we have learned in trigonometry, we have to revise that, and then we will talk about application of trigonometry. Will there be any theory? No, there is no theory as such in this particular chapter because all the theory is from trigonometry. So in this section of application, we'll be focusing only on one thing, that is on your marks. I simply mean that I'll be focusing upon the different kind of word problem or the question that will be coming from this chapter. So we'll be understanding the category or the type of questions we have in this chapter. So let's quickly revise now the concepts of trigonometry which we have already learned. So first thing first, what exactly was trigonometry? I defined trigonometry where we have a relation between the sides and the angles. So sides and the angle, this relation basically is the study of trigonometry. So trigonometry, again, if you can break it down, it relates to a triangle. It relates to the study of a triangle. This was trigonometry. In this particular section, we will be focusing upon what? The relation between the sides and the angles, and this relation can be easily developed using trigonometric ratios which we learned in the segment of trigonometry. Ratios was the method of comparison. Over here in a triangle, we are going to compare any two sides of a triangle, and in a specific over here, our focus will be on a right angle triangle. So when you have three sides in a right angle triangle and you come up with a comparison of any two, so in this way you will come up with 6 types of the comparison. So here we have the 6 ratios which we call as trigonometric ratios. Their names are as such: sin theta, cos theta, tan theta, cosec theta, sec theta and cot theta. Now most important one are the two, sin theta and the complementary of sin theta which is called as cos theta. Complementary of sin theta, that is why it is called as cos theta. What exactly is sin theta? Sin theta is the relation between the perpendicular and the hypotenuse in a right angle triangle. Perpendicular, which most of you call by the name of opposite side. This is the opposite side, this is the adjacent side. What exactly is opposite and adjacent side? If we are focusing upon this angle, this is our viewpoint, so the side which will be exactly opposite to this angle, this is the side which will be exactly opposite. So we'll call this side as the opposite side, or in a general way we call this as a perpendicular. If this is the opposite side, so this side which is adjacent, or I would say making up the arm. I hope you know the angle. If someone asks you what exactly is angle, you can explain it using a door. So door right now is closed. When you open it up, so some angle is formed, some distance between the two arms of that door is called as angle. So over here, this is one of the arm and this is adjacent to the angle, and hence it is called the adjacent side or simply the base for this particular triangle. For this side over here, which I have represented by H, I don't think I need to explain a lot about it because I already talked about the right angle triangle, the Pythagoras theorem, and the longest side we called as hypotenuse. So sin theta is the relation between perpendicular and hypotenuse. The second important relation, which is the complementary of sin theta, is called as cos theta, is simply the relation between base and hypotenuse. The relation between base and hypotenuse. So we have two relations, first of perpendicular with hypotenuse, then with base with hypotenuse. Now if I remove this hypotenuse altogether from this scene, what we get? We get perpendicular and base. So perpendicular and base is the relation which is called as tan theta. The name comes from tangent. I hope you have learned in circles. Next, we talked about that from these ratios we can derive a few ratios. Like what? From sine theta, if I take the reciprocal of sine theta, I'll come up with cosec theta. Cosec theta is the reciprocal of sine theta. Similarly, from cos theta, I can come up to sec theta, which is again a reciprocal of cos theta. And from tan theta, I can reach up to cot theta, which is again a reciprocal of tan theta. Very simple thing, if these three ratios are known to you, these three can automatically be calculated. And if these two are known, or I would say only one of them is known, you can calculate all of them. We have done a question related to that as well. But a relation between sine theta, cos theta along with tan theta is also there. That should be known to you. That is like this. Sine theta, if divided by cos theta, will give you what? Will give you the value of tan theta. This is the relation of tan theta with sine and cos as well. So each and one are interrelated. It's a family. It's a family. So someone is the mother, someone is the father, someone is the brother, sister, sibling, so and so and so. So basically all of them are interrelated and interchangeable at this moment as well, because their organic linkage is there. Organic linkage is the sides of a triangle. So using that you can convert them, and that's what we do in identity as well. Before I come to the part of identity, let me talk about the ratios value for a specific angle. We have talked about that what is the use of these ratios which we have learned. So when I say sine theta is equals to perpendicular by hypotenuse, how would we use this part? For that, if we know that the value of theta, that angle value is known to me as 30 degree. So something comes up for me. I know that sine of 30 degree is 1 by 2. Sine of 30 degree is 1 by 2, and that is really helpful if any of the one side is given to me. Let's say if perpendicular is given to me, using the angle, I can calculate the hypotenuse, and that is why it is a study of the relation between the sides and the angle. Till now, if only the sides were known, you were required to know at least two sides. By using Pythagoras theorem, you used to calculate the third side. But in this case, only one angle and only one side will make things work for you perfectly. So it's important that you know a specific angle values of these ratios, sine theta, cos theta. In this, I have told you the basic observation to focus upon not defined. Why it is not defined? Because 0 was there in the denominator. The value of sine theta and cos theta are mirror image of each other. 0 over here, 0 over here, 1 over here, 1 over here. Other than that, sine theta and cos theta remains between 0 and 1. The other rest of the four ratios have the value greater than 1, and the reason is very simple, because if I talk about cosec theta, it is reciprocal. So if this is 1 by 2, definitely it will be greater than 1, so it is 2. And again, once again, not defined because 0 was in the denominator. These were all the observation. Whoever have seen my previous lecture would be feeling, sir, this is all we have already learned, talk about the application. So I'll come to the application. One last thing over here was trigonometric identities. What are identities? If till now you are not clear about the word identities, then you are not revising well and you are not making the best out of these session. Identity is something for which each and every value fits well. So if you take any value for theta, that will fit for this given identity. It will satisfy the given identity over here. If I take theta as 90 degree, so sine square 90 degree plus cos square 90 degree will give you the result as 1. So these three identities were there, which we have learned in the previous session. And in these three things, what we have learned, these are interrelatable. So if someone is asking you about cot square theta, using this identity, you can find the value of cosec square theta. So these things, make sure you have taken a note of them, you are revising it, and most importantly, in trigonometry, many questions comes related to the proving part. So you are doing that proof questions because these are most important one. Now, enough of the talk for trigonometry. Let's give some weightage to this chapter for which we are conducting this session. So we'll start this session, as I mentioned, with very basic theory, nothing much involved. So what exactly is this? As I mentioned, the application relates to the height and distance. The name is synonymous. Application of trigonometry, or I might say heights and distance. Both are the same thing. So what theory do we have in this particular chapter? You see, The first example I gave you related to trigonometry was, let's say you are standing somewhere. I gave you a simple example. Let's say I am standing over here and you are standing in front of me. Both are having same height. So would I need to incline my head up or down somewhere? Is there any need? No, I will maintain it horizontally. That means zero angle would be there. But let's say now I'm standing against Burj Khalifa, a very tall building. Then in that case, I would have to incline my head up like this. And they would be angle made. They would be an angle made. So this is what happening over here. So here is a building. Here is a tall building. This is the tall building which I am viewing. This is my eyesight. This is my eyesight. From this eye point, I am viewing over here at the tip of this building. Now these are the 2 points, the tip of the building and from where I am seeing this part. These 2 points, if I connect these 2 points, the line which I get is called as the line of sight. A very simple thing, line of sight. What's new about it? A line of sight through which I am able to view something. Right now, if you are focusing into the screen, so that is your line of sight. Through that, you are getting a visuals. So same thing over here, this is the line of sight for us. This is the line of sight for us. And when I complete this figure, you might be very sure about the part which we have talked about multiple times, that this is a right angle triangle. This is a right angle triangle. If line of sight is clear, then we can come on to the next part, which is the angle. Because angle is the most important thing, because based on the angle, you will realize which is the opposite side, which is the adjacent side. And using that only, will calculate multiple things, which are heights and distances. So once the line of sight is clear, then this angle, what is this angle called? Since you have inclined your head upwards, you have gone upwards, so you are calling this as angle of elevation. You have to take your head upwards. This angle is called as angle of elevation. It can be anything. It can be 30 degree, it can be 60 degree, it can be 45 degree, it can be 85 degree as well. It depends on how tall the building is. Do you think any other factor it depends on? Let's say even if I am standing in front of a small wall, even if I am standing in front of a tall wall, not tall, sorry, short wall. If I am standing in front of a short wall, but the distance between the wall and me is very less. So what would happen? I have to see the wall like this, right? So that is the way the angle would be increased. Angle would depend on how far you are standing from the particular building. So right now, if I am standing in front of a very tall building, let's say it's a very tall building, but the distance between me and the building is very huge, very huge. In that case, the angle would be very reduced, let's say 25 degree. 25 degree. This 25 degree over here is the angle of elevation. This is our angle of elevation. Now, this is our line of sight. This is our line of sight. This is line of sight. This is our angle of elevation. Other than that, anything important, sir? Yes, another case can be there. I told you this angle is very small because we are standing at a very far distance. But there might be a case where the distance is very less. So let me draw that case as well if you are not able to visualize. Here we are having a very small building. Here we are having a very small building, and right now I'm standing over here. So what would happen? The angle would be like this. This is the right angle. This is the right angle triangle. In this case, the angle would be huge. So it totally depends how far you are standing from a particular building. This was about angle of elevation. Next, after angle of elevation, we have angle of depression. What do you mean? Let's say this time, right now, I am standing on the top of Burj Khalifa. I am standing on the top of Burj Khalifa. I got the chance to enter it and go on the topmost floor. Right now, everything is below me. Everything is below me. Now, if I am watching any particular person, let's say my friend is standing over there. So how would I watch? Like this? Because the person would be very small, somewhere down. So I would have to incline my head downwards. This time, rather than going up, which I called as elevation, I am going down, which is called as depression. So I am at the top of the building at the moment. And this person over here, which I am viewing, this is the point. So this is our line of sight, because this is my eye point, focus point. This is where I am looking to, and this is the triangle formed for me. This is the right angle formed for me. So over here, this is the angle of depression. Now, one interesting thing over here. Most of the students get confused when angle of depression is given. Always make sure that whether it's angle of depression or angle of elevation, both of them are calculated using the horizontal line as the reference point. Both uses horizontal line as the reference point. This is the horizontal line. This is the horizontal line which we are using over here, and this is our angle of depression. The angle which we are making by when we put our head a bit downwards. So this is our angle of depression, and this is using the reference as the horizontal line. Another important thing over here is Now, if this is the angle of depression, I hope you guys know the parallel lines. You know the parallel line. These are the parallel lines, right? These are the parallel lines. Over here, this is our line of sight. This is our line of sight. If this angle is known to me, what do you think would be this angle? If this angle is A, don't you think this angle would also be A? Do you remember any property? Do you remember any property? These are alternate interior angle. Interior, basically, these both angle lies between the two parallel lines. Between the two parallel lines. So they are interior. They are interior. And interior also they are on the alternate side. If this is the transversal, this is on this side, that means on the right side, and this is on the left side. So alternate interior angle, and hence these two angles would be equal. The point was, if this angle is given and if I say that this is my right angle triangle, so basically I know this particular angle. I know this particular angle, because most of the students get confused when the angle of depression is given. Two kind of a mistake they do. First mistake is, rather than taking this as the angle of depression, they take the other part. They take this part as the angle of depression, which is totally wrong. And other than that, when this is given, they are confused. If this is the right angle for me, how would I start the calculation? Because this lies outside of the right angle. That's not the case, because I told you the concept of alternate interior angle, which I expect you would be knowing already. Alright, so that is all in the theory part which we have for this particular chapter. Now, not wasting any more time, let's come to the questions which relates to all this what we have learned. So here we have the question. My humble request to you would be that since the questions are in front of you, you have the options. You can pause the video and start solving on your own. And once you are done, you can again open up the video and then see how I am doing, whether both the method relates, and most importantly, whether you reach to the correct answer or not. What happens in this process? If you are getting a wrong answer, or if you are stuck at a particular point, so in that case, you can able to relate, okay, this is the method I should go forward with. This is the correct way to go forward with. So in this active process of learning, you will remember more. Otherwise, what most students do, okay, sir is teaching right now, no need to do anything, let's just sit and watch sir. Nothing will happen with that until unless your multiple senses are working at the same time. You are writing also, you are visualizing, you are listening. If you are involving multiple senses at the same time, the learning is much more active and you will remember it for very, very long. So that was a little moral science from my side. Coming back to the mathematics and reading out the question loud over here. It says a tower is 100√3 meter high. Now, in such scenarios where we have the application of trigonometry, the first thing which I would suggest everyone is always start by drawing the figure. Always start by drawing the figure, because at the end of the day, when you are calculating any particular thing, you should be visualizing that thing very well. So, first thing is the tower is given and its height is given to you. So, let's say, whatever be the case, if it is a tower, if it is a building, if it is any other thing, I'll draw by a line. I hope you understand that this much liberty I can take rather than going for the building of a tower, rather than going for drawing Eiffel Tower for you. I can just go forward with drawing a simple line. So here we have a tower whose height is given to me as 100√3. 100√3. Find the angle of elevation of its top from a point 100 meter away from its foot. So they are saying that they need to find the angle of elevation. One thing clear, what they are asking in the problem. Next thing is from a point 100 meter away from its foot. From its foot, this is its foot. So 100 meter away, somewhere over here. This is 100 meter. This is 100 meter. This distance is given to me as 100 meter. So this is somewhere I am standing. Now these are the two end points. So this is our line of sight. This is our line of sight, and this over here would be our angle of elevation. This theta would be our angle of elevation, and this is what we need to calculate. So if in a triangle, one side or basically two sides are given, can I relate the two sides of the angle? Yes, trigonometry gives me that liberty. Allow me, make me understand that how we can relate. If two sides are given, if this is the angle, for this angle, this is the opposite side. For this angle, this is the opposite side. So basically this is the perpendicular for me and this is the adjacent side. If you remember, what is perpendicular by base? That is why trigonometry application. Perpendicular by base is called as tan theta. Tan theta. Alright, So this relation, now I know that tan theta is perpendicular by base. I have been given the value of perpendicular. I have been given the value of base. So let me put the value. Why waste any more time? 100 root 3 divided by 100. 100 root 3 divided by 100. I will cancel out these 100 on both the side. 100 cancel out with 100. I am left with tan theta. Tan theta is equals to root 3. If you are not able to see, now we can see tan theta is equals to root 3. If you remember that table which I have shown, or if you have already learned that table, then you will be easily answering this question, because root 3 is the value of tan 60 degree. Tan 60 degree. I hope you are able to understand. I am revising once again. Tower height is given, so this is the perpendicular height given. Angle of elevation being asked over here from the top of a point 100 meter away. 100 meter away. So this distance over here from the foot is 100 meter away. Perpendicular base. Perpendicular by base. Value is 100 root 3 divided by 100. That is the base value. And this angle over here. So perpendicular upon base is tan theta. Tan theta, when I calculated, when I reduce these part, 100 gone, root 3 is left. Root 3 is value of tan 60. From here, I can say that theta is 60 degree. Theta is 60 degree, and hence I have calculated the correct answer, which is option number B. Option number B. This is how we apply, this is how we use our trigonometry, this is how we use the value for a specific angle for trigonometric ratios. Important thing was drawing of the figure. If you are reaching to the point where drawing the figure correctly, that means you are perfectly right on good track. Alright, moving on the next one. This time, rather than having a tower, this time they have reduced their status and come down to a ladder. They say a ladder 15 meter long. A ladder is 15 meter long, just reaches the top of a vertical wall. So a ladder would be needing a wall to rely on. So here we have a wall, and here we have a ladder. Here we have a ladder. All right. Now, they say ladder is 15 meter long. So this distance is given to me as 15 meter, because ladder length is 15 meter. So if it is inclined, so that inclined distance will be 15 meter. Top of the vertical wall, this is the top of a vertical wall. If the ladder makes an angle of 60 degree with the wall. Now, what kind of a mistake a student will do in this particular problem? They will not see here or there. They will directly make this angle as 60 degree. They will make this angle as 60 degree. But that is the point. I say always that always read the question multiple times. What happens? You will get to know your mistake. The ladder makes an angle 60 degree with the wall. Not with the floor. With the wall. This is the wall. So over here they are making an angle of 60 degree. Here they are making an angle of 60 degree. And you already know this is 90 degree. This is a 90 degree, because wall and the floor will be having an angle of 90 degree. The point is, tell me now, what will be this angle? What will be this angle? If this is 60 degree, this is 90 degree, don't you think this will be 30 degree? Why? 60 plus 30 is 90, 90 plus 90 is 180. This is grade 7th math, so no need to teach you again this part. Why I calculated this angle? Because that will help me very easily to calculate what have been asked. Calculate the height of the wall. This height have been asked. This h value have been asked to me. Alright, this h value have been asked to me. If this is the angle, so the opposite side is this one. This is our opposite side. So I have been asked about perpendicular. So rather than taking it height as h, let me write that value as simply p, so that you don't get confused. Let me write the height as simply p. I have taken the height as p. So this is our opposite side, which I am calling as perpendicular. So I have been asked about perpendicular. The side given to me is the hypotenuse. So I am taking the relation between perpendicular and hypotenuse. Perpendicular by hypotenuse is what? It is sine theta. Which theta? This one. So sine of 30 degree. Let me write sine theta first. Sine of 30 degree over here. Sine of 30 degree over here have been given as perpendicular by 15. Perpendicular by 15. This value I know is 1 by 2 is equals to p by 15. From here, what do I get? I get the perpendicular value, because I know you are very comfortable doing the linear equation. So from here, the perpendicular value will be, by after cross multiplication, will be equal to 15 by 2. 15 by 2. This is our final answer. Do we have the option? Yes, sir, we have option number C. And we have option number C as the correct answer. So what kind of a mistake in this question we can go for? We can go for, rather than making this angle as 60 degree, we make this angle as 60 degree and end up with a wrong option over here. Avoid this mistake. What was the thing which we need to learn? Read the options or read the question very, very carefully. Next question now. This time things seems to be much more magical. A circus is there. A circus artist is climbing along a rope stretched from the top of a vertical pole. There is a vertical pole and now they have tied a rope over there and then elongated that rope. And along that rope, a particular person is climbing. So let's draw it over here. Here we have a vertical pole. Here we have a vertical pole. And along that pole, we have tied up a rope like this. They say the circus artist is climbing along that rope. From here, he is climbing. On the top of a vertical pole of height 12 meter. Vertical pole height is given to me as 12 meters. So this distance over here is given to me as 12 meter. And the angle made by the rope with the ground, is 30 degree. So this is the rope and this is our ground. This angle is given to me as 30 degree. Fair enough. Reading the question is very, very important. So after that, what they are asking, the distance covered by the artist in climbing to the top of the pole is. This particular distance they are asking because this is the way he is going up. He is going up using the rope. He cannot directly climb up on the vertical pole. He is using a rope to climb up. And this distance they are asking. So this is a hypotenuse in a right angle triangle. Let me call it as H. This is our hypotenuse in a right angle triangle. This angle being 90 degree. One side given, one angle given, another side being asked. Things seems to be very, very simple. Think about it. What kind of a relation can we use? Perpendicular hypotenuse, because this is the opposite side. So perpendicular hypotenuse, P by H. So this is the relation which we can use. So P by H is the relation of sine theta. Sine theta is equals to P by H. Angle is given to me as 30 degree. Sine of 30 degree is given to me as, the perpendicular value this time is given. Last time it was not given. Last time it was asked. This time it was given to me. So this is given to me as 12 by H. Let me put the value. This is 1 by 2 equals to 12 by H. Again doing the cross multiplication, I can calculate the value of H over here. Actually what? 12 into 2, that is 24. 24. What? Meter or centimeter? It's important to take the measurement because centimeter, that means this much distance he will be rising up. So that doesn't make any sense. It has to be 24 meter. In the subjective problems, units are very important. You may realize this importance when you go in grade 11th, where the first chapter of physics is units and dimension. Units are very, very important. Option number A with the correct answer. I hope you realize the problem over here. Now, next one. They are saying the angle of elevation. Finally, someone used directly the angle of elevation. The angle of elevation of the top of a tower from the point on the ground, which is 30 degree away, so not 30 degree, 30 meter, the unit importance. 30 meter away from the foot of the tower is 30 degree. A lot of information I was not able to process. Let me break it down in simple terms. First of all, the angle of elevation of the top of the tower. Angle of elevation, this is our tower. So this will be our angle of elevation. Now I can complete our right angle triangle. Off top of the tower from a point on the ground, from this particular point on the ground, which is 30 meter away from the foot of the tower. So this is our 30 meter distance from the foot of the tower. This is our foot and this is where we are standing. So the distance is given to us as 30 of the tower is 30 degree. What is 30 degree? See, this is the how they can confuse you. Such a long sentence they have given. They have told angle of elevation. Now they are coming to the part. Angle of elevation is 30 degree. Directly they could have told you. They could have made this question very simple by simply saying angle of elevation is 30 degree and the distance between the foot and the person is standing is 30 meter. Things would have been very simple. But no, they want to make things complicated for you. But you are a smart person, so you'll be able to easily answer. So angle has been given to you as 30 degree over here. The height of the tower is asked. So this particular height over here, which I am calling as P. Why? Because I like P. This is my particular word, perpendicular. I'll use as P. So this particular height have been asked. Perpendicular, this is the base. Why perpendicular? Because from the angle's perspective, this is the opposite side. This is the opposite side. I have a perpendicular, I have a base. Perpendicular by base is the relation for tan theta. For tan theta. and I want what? I want perpendicular. So tan theta, I'll put the value of theta over here. Tan of 30 degree equals to, perpendicular is the thing which I need to find, and the base value is given to me as 30. Tan of 30 degree is 1 by root 3. This is something which you should be knowing on your fingertips. That is the importance of this part. P by 30. From here, I get the value of P as 30 by root 3. Now, you might say, sir, this is the wrong answer. This is the wrong answer. Each and every question have a new concept. Each and every question have a new concept. Now, in this case, the option is not matching. Why the option is not matching? You must have learned something called as rationalization. Rationalization. Over here, we are having a denominator which is irrational. So, you need to rationalize that. How? You need to rationalize by multiplying with the same denominator in the both numerator and denominator. What are you saying, sir? I'm not able to understand. So let us make you understand over here. Once this is done from your end, the next step has to be to do the calculation. To do the calculation so that this irrational number is removed. For that, you will multiply by root 3 in both numerator and denominator. When you have the same denominator over here, root 3, I hope you know that root 3 multiplied by root 3. In the square root part, we are having 3 into 3. So, pair is being formed, 3 will come out. So, in the denominator, we are left with 3 only. We are having 30 root 3 by simply 3. So, ultimately, when you do the calculation, we'll come up with 10 root 3. And this is our final answer. This is our final answer, which matches with option number D. This was the concept which was new in this particular question. Each and every question have a new thing. So this is the one which we had. Understood? Next one. Now, a pole casts a shadow of length 2 root 3 meter on the ground. A pole is there. Fine. It casts a shadow. So shadow is casted like in this manner. Alright. So there would be some shadow, a portion of black region which you see on the ground when you are standing, and the sun is behind you. If the sun is in front of you, the shadow will be formed on the behind. If sun is behind, the shadow will be on the front. So if I am creating a shadow here, so the sun would be somewhere over here. I hope this is not that difficult to understand. You all understand physics. Physics and mathematics are all interrelated. All interrelated. If you are not clear in one concept, you will be struggling in other concept. So make sure that you are learning each and everything. It's not like, okay, in the examination, this is the weightage for this particular chapter. I'll read only this much. I'll skip this part. That's not how studies work, because you are not studying just to gain marks. You are studying to learn science. You are studying to learn each and everything around yourself. Coming back to the question, this is the sun, this is the shadow cast. What they are saying? The pole casts a shadow of length 2 root 3. So this is the shadow. So length of this part is given to me as 2 root 3. Fair enough. On the ground. When the sun's elevation is 60 degree. If this is the sun, so elevation would be like this. This angle is given to me as 60 degree. This angle is given to me as 60 degree. The height of the pole, this height is being asked, and as you know, so that you have to focus in the session over here, I call the height by the name P. I call the height by the name P. P, base and the angle, everything seems to be as usual. The important thing in this question was this sun and the angle of elevation, because this kind of a question comes and people do get confused how to draw the figure. This is how you need to draw the figure in this particular case. So I'll write it directly, because now we already know what relation we are talking about. We are talking about tan theta over here. We are talking about tan theta, and theta value is specifically mentioned over here. Tan of 60 degree is given to me as the perpendicular by base. So P I don't know, base I know as 2 root 3. Tan 60 is root 3. Tan 30 is 1 by root 3. Tan 60 is root 3. So root 3 is equals to P by 2 root 3. From here, the value of P comes out to be 2 multiplied with 1. I hope you know the multiplication of rational number with irrational number. 2 with 1 will remain as it is. Root 3 into root 3 we have done in the previous question. So 2 into 1 will be as it is, and root 3 will be 3. So 2 into 3 is 6, and some unit would be there. Meter has been used, so I'll write as 6 meters. This is the height of the pole, which matches with option number B. So here we have a very simple answer for the very simple question. This is the kind of question they ask generally. All these MCQ questions done, and very easy and simple questions they all were. Now let's change something. Let's change the pattern over here and come to some subjective kind of a problem which demands a lot more than what you expect. Here we have a question, and this time this is much more complicated because this time they're asking you to change some few things. Over here they say a tree is broken by the wind. A tree was like this, now it is broken. This cannot be broken at the moment, but you can assume, okay, this was the tree and now it is broken like this. So over here tree was there like this. A tree was there like this. It is broken by the wind. So somewhere at this point it will be broken, or whatever be the point at the top towards the bottom side. So wherever it is broken, it will fall something like this, something like this. When it is falling something like this, I can complete this right angle triangle. Now over here, what happens when it falls onto the ground? It makes an angle of 30 degree with the ground. 30 degree. And at a distance of 30 meters from the roots. So this would have been the roots. Biology thing, I like it. 30. This is the root, so the distance from the root is given to me as 30 meters. So this is 30 meters for me. What I have been asking? Find the whole height of the tree. So this complete length they are asking. At the moment for me, when I have drawn the figure, the thing is not complete. The thing is broken into two parts. So let us start by assuming two different things. Let me call this thing as y and let me call this as x. If this is y, this is x, what will be the height of the tree? Height of the tree would be x plus y, and this is what we need to calculate. So basically I need to calculate the value of x and the value of y. It's not complicated because if you focus on the right angle triangle, one angle is given, one side is given. This is all what we need. For a triangle, we need only two dimensions, either two sides or one side or one angle. So over here we have both the utilities available at our hand. So let's make good use of it. We have this as y, this as the base. Let me say this is the opposite side because this is the exactly opposite side. So I will use 10 theta, which will be this as perpendicular, this as base. So y upon 30 degree. Theta is 30 degree. 10 of 30 degree equals to y upon 30. From here, putting up the value of 10 theta, that is 30 degree, 1 upon root 3 equals to y upon 30. From here, the value of y will be equal to what? 30 going on this side, so 30 upon root 3. But I don't like this. I don't like this. I told you in the previous question, I don't like the manner when the irrational number is in the denominator. What we need to do? We need to do the rationalization, and since I have done it already, I'll not repeat it once again. I'll directly write it as 10 root 3. 10 root 3. I have put the value of y. I have got the value of y. One part is solved for me. I need to calculate the value for x as well. For x, this is the part, this is the part, this is our hypotenuse, this is our base. Hypotenuse and base are there. Or let's say if this is the part of perpendicular, this is the part of hypotenuse, perpendicular and hypotenuse relation we know. So let's use it. Sine of 30 degree. Sine of 30 degree is perpendicular by hypotenuse. Sine 30 degree is 1 by 2. Perpendicular, you say what is perpendicular, sir? Perpendicular is y, which we have already calculated. What we have calculated? We have calculated the value as 10 root 3. And hypotenuse is what we are going to calculate this time, and the question will be done once and all. So let me call it as x. So from here the value of x comes out to be what? 2 into 10, that means 20 root 3. Would this work for me? Would this work for me, 20 root 3? Yes, this is working very, very good, because over here the irrational number is in the numerator, not in the denominator. X value is found out, y value is found out. Now we can call the height as, the height will be what? Height we have called out as x plus y. And we know the value of x and y, so height will be what? 10 root 3 plus. This we have calculated 20 root 3. 20 root 3. I hope you are good at addition, because the addition is very simple. We have 10 plus 20, 30 root 3 is the height of the tree. This is what we have asked. What was important in this question? The importance of this question was just to make you realize, using one simple question they can ask you to do the same calculation 2 times. How 2 times? With the same right hand triangle. If you remember, in all the previous questions, what we have done? We have used the relation of angle and the trigonometric ratios once. In this particular problem, subjective problem, we have used the relation 2 times in the same right angle, and hence we were able to find the value of x and y separately, and we know now that this length would be what? This length would be 30 root 3. Alright, that's how this question needs to be tackled out. Nothing to worry about. Previous questions were of 3 marks, so this question would be of 5 marks. That's it, nothing more than that. So let's solve one more question related to 5 marks if you're interested in the marks part. Next and the final question of the session is here. It says an observer 1.5 meter tall is 28.5 meter away from the tower. So first of all, let me draw the person. I don't know what is the gender. But I know the height. This is given to me. This is 1.5 meter. 1.5 meter. Fair enough. Is 28.5 meter away from a tower. So I know this distance. 28.5 meter. And this is our tower. Alright. The angle, the elevation of the top of the tower from her eyes is 45 degrees. So this is the horizontal thing for him, because angle of elevation has to have a reference point which is horizontal. So the angle of elevation to this particular top is given to me as 45 degree. This is given to me as 45 degree. Important thing in these problems are to draw the figure correctly. If the figure is drawn correctly, you have got the answer. If the figure is not right, the answer, whatever the calculation you have done, whatever amount of time you have wasted, it will be a total waste. Nothing more than that. 45 degree. Anything else? Find the height of the tower. Now, they're asking the height of the tower. This is the height of the tower from this point to this point. Don't get confused, only this much is the tower height or this much is the tower height. This is the person height. If the person height is given to me as 1.5, let's make the use of it. This is 1.5 over here. So this distance over here will also be 1.5. Similarly, if this distance is 28.5, this will be also 28.5. How, sir? Why are you like easily using that? Okay, this side is equal to this side. Over here, this is what? This is a parallelogram. This side will be equal to the opposite side. This side will be equal to the opposite side. So this is 1.5, this is 1.5, this is 28.5, this is 28.5. As simple as that. We have been given 45 degree. 45 degree is my favorite angle. Why, sir? If 45 degree is given, I know one thing. What is that? Tan theta. Tan theta is what? Perpendicular upon base. If tan theta is 10 of 45, if tan theta is 10 of 45 perpendicular upon base, that means 1045 is what? Taking so much time. 1045 is simply 1. This is perpendicular by base. That means perpendicular and base will become equal. Wherever you find the value of theta as 45 degree, in that case the perpendicular and the base will be equal. Perpendicular and the base will be equal. If this would have been the perpendicular, this is the base, they both will be equal. Let's add some color over here. It was getting very black and white. So over here, if this is 28.5, this would have been our perpendicular and this would have been our base. So this perpendicular height we have already calculated. This is equal to the base part, which is 28.5. 28.5. Perpendicular is equal to the base, which is equal to 28.5. Is this our answer? Why are we so happy? The answer would be to find the after the height part, and height is the complete distance. If this much part is known to me, this I have already told is the height of the person. There was the reason the person height was given. There is a reason the person height was given. You can use it now by simply adding to the remaining height of the building. If this is the remaining height of the building, if added with the base part, this will be the complete height. So height of the building would be what? 28.5 plus 1.5. And now you can do the addition of decimal, which is again a very basic mathematics. You will come up with the result of 30. What? What is the unit? What is the unit? Meter. 30 meter. Can it be kilometer? Can a building be 30 kilometers long? No, that's not possible. Concept in this problem, what was the concept? This problem was there to make you learn the understanding of this particular height of any person. If this is given, so you have to draw that this is the rectangle or this is the parallelogram, whatever way you want to think, and you will add this amount of distance in the calculated amount of height which you have done using trigonometric ratios. And I told you why 45 degree is my favorite angle. So this is all what we had in the application part, and I hope you have enjoyed this short and crisp session. I didn't want to elongate this particular session for very long, because then it would have gone on the same slope. I don't want the same slope. I want some angle of elevation, not the depression part, the angle of elevation. From my end, that's all. I would ask you a humble request to all of you that take up your textbook and practice more questions on the application. They all would be of the same category, because I have taken all the types of question possible in this particular chapter. So that's all. Have a great time. Enjoy yourself. Bye bye.